Hello everyone, welcome to our day 13 discussion. Today we are going to discuss about the optimizing pod scheduling with node affinity, taints and toleration. Let's do a quick recap what we have discussed in our day 12. In our day 12 we discussed about the management of environment variables. So to implement this one, the first option was using plain key, means in the pod we mention the key and values. The second option which we have discussed is config map. In real-time scenarios, we are going to have n number of keys and values. So in that case, we need to have one file where we are good to store all the keys and values, and then we are good to inject this keys and value inside our pod configuration. Okay. And the third one which we discussed is regarding the secret. I would say if you want to connect to your database, then you need to mention what? A username and password. Okay. Or I would say the URL also, the database URL. Do you think it would be a good idea to mention this in a plain text? The answer is no. Okay. So to store this confidential data, we need to use secret. The issue with this secret is it works on the principle of encoding, which you are good to decode without any issue. That's why the secret options are not used in real-time scenario for storing our confidential data. So to implement this one, as we have discussed, we need to use third-party tool. Okay, so we have n number of third-party tools according to the cloud environment which we are using. In Azure, we have Key Vault. So we discussed about the implementation of Key Vault. So the first thing which we discussed is our virtual machine skill set, which is eventually our AKS cluster. Here we need to enable what? We need to enable CSI driver, and then this CSI driver will create one manage identity, and then this manage identity we need to give the access to our key vault where we have stored our secret. And then finally we need to create secret provider class where we have a information regarding the key vault, the keys, the tenant ID and the other configuration. And finally we are going to mount this secret provider class inside our vault. So this is the way in which we have saved our secret inside the key vault, and when when we are going to log in inside the pod and mention env, which we would be able to fetch the values which we have stored in our key vault. So these are the things which we have discussed in our day 12. So let's start our day 13 implementation. To implement our day 13 things, I have already created a cluster name called as demo-aks. Okay, and in this demo-aks I have one system pool. Okay, I'm going to quickly create some other pools also, like a small pool, medium pool and large pool. Okay, let me quickly log in inside my AKS portal and create all these three new pools. So I have logged in inside my Azure portal and I have already created demo-aks cluster. Let me create a new node pool, and my new node pool name is small pool, and then I'm going to select the size. I'll mention D2S version 5, and I will select the scale method as manual. We'll let it be 1 only, and then I will click on review plus create and click on create. We'll create a nest pool. The name of the pool is medium pool, and here I'm going to select the scale method as manual, and then I'm going to click on review plus create. And I'm going to create another node pool name called as medium pool. We'll select the scale method as manual and we'll select the node size as D2S V5 and we'll click on review plus create and then file and then we'll click on create. And finally, the last pool which I have to create is large pool and we'll select the size. It would be same D2S V5 and then I'll select the scale method as manual and we'll click on review plus create and then on create. Okay, so it will take some time to create all the three node pools. And if you see here, all the three node pools have been created and the state is running. Okay, let's start our today's discussion. Okay, so in Kubernetes architecture, we already have a detailed discussion. What is the function of scheduler? Okay, as we have discussed, scheduler works on the three principles. Firstly, it is going to be filter, then it is going to score, and finally it is going to bind. Okay, filter means if you have n number of worker node, it will select what are the node it is good to select, and then finally whatever the node it has selected in the first stage will try to score it, and whatever the node has the highest score will finally bind it. I would say if I have worker node 1, worker node 2, worker node 3, here it would come worker node 1, worker node 2, whichever one has the high score, that would be bind to create our pod. So this is the part which we have discussed. Okay, so let me quickly connect to my Kubernetes cluster also. So I'm going to click on overview. We'll click on connect. We'll click on set the cluster subscription. I'll open the CMD and here I'm going to mention the subscription. The next thing which I'm going to do, download cluster credential. We'll copy it. We'll paste it here. So finally our kubeconfig file has been updated. I'll mention kubectl get nodes. And if you see here, we are able to see all the nodes. Okay, so till now what we have done, if we are going to create any pod, I would say kubectl create, I would say kubectl run nginx. So let me create a one pod name called as nginx. Okay, so our pod has been created. I'm going to run kubectl get pods hyphen o white, and if you see here, the pod has been created on this pool name called as large pool. Okay, have I mentioned anything here like on which pool do I need to create this pod? The answer is no. This node has been selected by our scheduler. Okay, and as we have discussed, scheduler has its own principle like filter, score and bind. Okay, let me create one more pod. Okay, I'll update the name as, I will add some random number to make the pod unique. Let me run this command again. If you see here, again my pod has been created in large pool. Let me create a third pod. Again we'll add some random number to make it unique. The pod has been created, and if you see here, again my scheduler has selected the large pool only. Let me try last time and see, is it going to create my pod in this large pool, or else it is going to select some other pool like medium pool, small pool or system pool. And if you see here, finally, the initially 3 pods have been created inside the large pool. Okay, when we initiated the fourth pod creation, it has been created inside our medium pool. Okay, so whatever the pod we are creating, and selection of the node pool is done by the scheduler, so we do not have any control. Let's take example. Okay, I am creating a pod, and this pod should be created inside the small pool. Okay, so in this case we are not going to take a help from scheduler. Okay, we are not asking scheduler, okay, just filter it, score and bind. No, we do not need any help from scheduler. We are asking scheduler, okay, I want to create this spot and create this spot in a small pool. Okay, so this process is called as manual scheduling. Why it is called manual scheduling? Because manually we are scheduling the pod to a specific node pool. Let's do a quick demo for it. I'm going to create a file name called .yaml. Okay, and here I'm going to mention about the pod configuration. If you see here, what we are trying to create, we're trying to create a pod. The name of the pod is manual schedule pod, and in the specification I have mentioned my container name is ABC, and it is going to use image nginx, and node selector I have mentioned here as a small pool. Okay, let me quickly run a command called kubectl get nodes. If you see here, we have 4 nodes present, and out of the 4 nodes, what I'm saying, I want my manual schedule pod to be created inside my small pool. Okay, let me run the configuration. I'll copy the path. I'll run kubectl create -f and run. And if you see here, my pod has been created. I would mention kubectl get pod -o y. The pod which we have created name is manual schedule pod. This one, it has been created inside aks small pool. Okay, if we are not going to mention this node selector, then our scheduler is going to decide where our pod is going to be created. But here we have mentioned, okay, scheduler, please create my pod on agent pool. That's why it has created my pod inside this agent pool, and this process is called manual because manually we have updated. Okay, I want to create my pod inside this one. Okay, so the next type of scheduling is called as node selector. Let me go back to the whiteboard. Okay, so the first scheduling is called as manual scheduling. So in manual scheduling, we are going to mention a specific agent pool where we want to create our pod. Okay, and there it would be created. The second type of scheduling, it is called as node selector. Okay, so what is the exact meaning of node selector? Before explaining the node selector, I would like to mention only one thing regarding this. The node selector works on the principle of equity based selector. Okay, I hope you remember what is the exact meaning of equity based selector. In equity based selector, we are good to pass only single value. We cannot pass multiple values to a single key. Means value 1, value 2 cannot be passed. We are good to pass only one value. This is called equity based selector, and no selector works on the principle of equity based selector only. So what we are going to do, we have three node pools, I would say. Okay, we have three node pools. One, it is called as large pool. The second one is called as medium, and finally the last one is called as a small pool. Okay, so in the large pool we are going to update the labels as large. Okay, I hope remember labels means what? A tag. So we are going to update in the large pool the label as large. Okay, and we are not going to touch the medium pool or the small pool, although we have one more pool which is called a system pool, but I am ignoring it because the system pool is dedicated for the system pods only. Although we are good to create the other pods, but it is not a good practice to create the application configuration inside the system pool. So this pool should be dedicated for all our system pods. So that's why I am focusing on the other node pools which I have created. So the first thing which I'm going to do, I'm going to update the labels as large in our large node pool, and then in my pod configuration, then I'm going to create what? A pod. And in this pod, I'm going to mention the node selector as large. And then I will try to see if this pod is going to be created inside my large node pool or a medium one or a small one. To implement this demo, the first thing which we are going to do, we are going to update the large pool with a large tag, and then I'm going to create a pod, and in the pod I'm going to mention the node selector as large, and then we will try to check, are we good to create this large pod inside the large node pool, medium one or a small one. Okay, let's do a quick demo to understand this one. Okay, as I have mentioned, the first thing which I'm going to do, I'm going to update the labels or tag for our large node pool. The command is az aks node pool update my resource group name, my cluster name, then my pool name and the label which I want to update. As I have mentioned, for my large pool I'm going to update a labels called as size equal to large. Okay, and finally our node has been updated with this label, and the label is size colon large. As we have discussed, the first step is to update the labels inside the pool, which we have done. Okay, the second stage is we are going to create a pod. Okay, and in this pod configuration we'll mention the selector for this label, and then we'll check is this pod is going to be created in this large pool or not. Okay, so let's create our YAML file firstly. If you see in this YAML configuration, what we are trying to create, we are trying to create a pod. Okay, and the name of my pod is nodeSelector, and here I have mentioned my container name as container, the image is nginx, and in terms of nodeSelector I have mentioned size colon large. Okay, and what is the label I have defined here? It is the same one. Okay, okay, then let me run the command kubectl create -f, and the name is nodeSelector.yaml. Pod has been created, And let me run a command called kubectl get paths -o. And if you see here, our pod node selector has been created, and it has been created inside which node pool? The large node pool. So we are good to say this thing is working good. Whatever the label we have defined on the specific node pool, on the same node pool, our pod has been created. So let's go to our whiteboard. So what we have done, we have created the three node pools, and in the large pool I have updated a label called as size is equal to large. Okay, and in my pod configuration I have mentioned node selector as large, and automatically my pod has been created inside the large configuration. Okay, how we are able to achieve this one? Using the node selector. So here comes very interesting question which we need to understand is, what is the difference between the manual scheduling and the node selector? The difference between the manual scheduling and the node selector is, if you see here, we need to mention the pool name which we want to use. I have mentioned here small pool. While in the case of node selector, we are good to mention here the labels. Okay, and what is the benefit of using a label? Right now I would say I have mentioned large pool only with label called as large. Okay, but maybe I have one more node pool which is, I would say, have the same configuration. I will mention here as large 2 pool. Okay, and if I'm going to label this one as large 2, then I'm good to implement using node selector one. Okay, but in the case of manual scheduling, that would not be possible. Okay, we are only good to pass single value. So this is the difference. So the next one which we are going to discuss is node affinity, and the node affinity works on the principle of set based selector. So we already have a detailed discussion regarding the node selector. The issue with the node selector, it works only on the principle of equity based selector, means we are good to pass only one value. If we are going to pass the multiple values, it, we can't use the node selector. So to use the multiple values, or I would say set based selector, we need to use node affinity. Okay, the third type is node affinity, and it works on the principle of set based selector. So here the interesting question comes, why we need to use set based selector? As we have discussed, in set based selector we are good to pass a single key, but we are good to pass multiple values. Okay, and it has its own component or operator in, not in, and exist. So we are good to implement the pod scheduling at a wider level. But before discussing the node affinity, firstly we need to understand some node affinity types. Okay, so what are the node affinity types? So what we have, I would mention node types affinity. Okay, we have three types of node type affinity. The first one, let me change the color. The first one is called as the first one is called as required during scheduling, ignored during execution. Okay, and the second type is called as preferred during scheduling, ignored during execution. Okay, and the third type is called as, and I would say the third type is called as required during scheduling and required during. Before doing the node types affinity demo, firstly we need to understand what are the different types of node type affinity. The first one is required during scheduling, ignored during execution. The second one is preferred during scheduling, ignored during execution. And the third one is required during scheduling, required during execution. Okay, so what is the exact meaning of it? Firstly, we need to understand two terms. It's called scheduling and execution. Okay, so we already have a very detailed discussion. What is the exact meaning of scheduling? Means whenever we are going to create our pod, our scheduler is going to be in action, and scheduler is the main responsibility to schedule our pod. If you want to control the scheduler work, means you want to deploy the pod on a specific node pool, then we are good to use the manual scheduling, node selector, or I would say node affinity. Okay, and what is the exact meaning of execution? Execution means once you schedule your pod will be in a running stage, and this stage is called as in execution. Okay, it is mentioned here required during scheduling, ignored during execution. So exactly what is required during scheduling and ignored during execution? So firstly we need to understand what is exactly required during scheduling and ignored during execution. The concept is same which we have discussed in our node selector. So in the node selector we discussed we have a large node pool, we have a medium node pool, and we have a small node pool. We are going to put a label here, means a tag we are going to create, and then at the time of our pod creation we are going to use the selector. But here in node affinity we are using what? Set base selector. So here we are good to pass multiple values while creating the pod. Whatever the node selector you're going to pass, it should match during scheduling. If it is not going to match, your pod will not be created. So what is the exact meaning of it? I would say I have mentioned here this one as large. Okay, and here I have mentioned this one as medium, and here I have mentioned the size is small. Okay, and in my pod configuration I have mentioned I want a pod whose size in small or large. Okay, so whenever my scheduler is going to schedule the pod, it is going to check if small level or large level node pools are present or not. If both of them are going to present, then only my pod is going to be created, or else it would not be created. Okay, that's the meaning of required during scheduling. Okay, while in the case of preferred during scheduling, it will try it best, means our scheduler will try it best to schedule this pod small in small or large node pool, but it is not 100% guaranteed. Okay, again in the third case it would be same. Required during scheduling means our pod, whatever the level we have defined, small and large, it is mandatory to match any one of them node pool to create. If none of them are matching or none of them has the available resources, then my pod will not be created. This is the all about required during scheduling, means at the creation of our pod. Okay, so what is the exact meaning of execution? As I have mentioned, execution means at the time of running, which means I have created my pod and it has been created inside my large node pool. And after 30 minutes, what I'm going to do, I'm going to remove the label of size equal to large. So in this case, if it is mentioned ignored during execution, so my pod will not be terminated. Even in this case, it will not be terminated. But if you see here, required during execution means in this case, after 30 minutes, if I am going to update the labels, means I'm removing it or I'm updating the labels, and it is not going to match whatever the labels we have defined while the creation of pods, my pod will be in terminated state or it will be in pending state. Okay, so let's do a quick demo to understand the node affinity. So for this node affinity, I already have three pools: large, medium, small. I'm good to ignore system pool. Let me run a command: kubectl get nodes. Okay, so currently we have the four nodes. So what we are trying to achieve, the first step, I'm going to create a label for my large and medium. I've already done this in the last demo, so we are good to ignore it. So we are going to update our medium node pool, and the second thing it would be to implement our pod. Okay, let's do this. The node pool update, the resource group name of my AKS cluster, my AKS name, the name of my pool, and finally the label which I want to update. Let me run it. And if you see here, finally in our medium pool also this node label has been updated. Let me quickly check inside my large pool also. The command is kubectl describe node, my node name, and finally hyphen pipe find str hyphen I size. Size is my key and the value it would be large. See, the value is size equal to large for my large pool. Okay, so we are done with this first step. It has been completed. The second step which we are going to do to create our pod. If you see in this YAML pod, what we are trying to create, we are trying to create a pod. The name of a pod is RNA pod, and in the containers configuration, the name of my container is node container and the image is nginx. Here if you see from line number 9 to 18, it is mentioned in terms of node affinity. Okay, so which node affinity I have mentioned? I have mentioned required during scheduling, ignored during execution. Okay, which means at the scheduling time, whatever the values I'm going to mention, it should be present. Means with this key size, any one of the values should present. Either the size is equal to large should be present, or size equal to medium should be present. And here it is hyphen, means we are good to pass n number of values. So then it is mentioned ignored during execution. So we already have a very detailed discussion. In the large node pool, we have a tag called large, and a small node pool, we have a tag called medium. Okay, so it is going to work. What I'm going to do, I'm going to update some random number, and then I will try to check, are we good to create the, I will say 1 2 3, and here I'm going to say 1 2 3. So with this value we do not have large 1 2 3 and medium 1 2 3. So as per our discussion, when my scheduler is going to follow this rule required during scheduling, it would not be able to find any node pool which have this configuration, so it would not be scheduled. So I'm going to run a command called kubectl create hyphen f and node affinity dot yaml. Oh, okay, there is one typo. Okay, my pod has been created. Let me run a command called kubectl get pods. And if you see here, my RNA pod is in pending state. Why it is in pending state? Let me run a command called kubectl describe pod, and the name of my pod is RNA pod. And see what we are getting: failed scheduling. Why? From default scheduler, means our scheduler is trying to schedule this pod on the specific node pool which we have mentioned, large 1 to 3 and medium 1 to 3, but currently we do not have any one of this node pool. So see, 0/4 nodes are available. 4 nodes did not match the pod node affinity selector. 0/4 nodes are available. 4 preemption is not helpful for such scheduling. Okay, so whatever the things we have mentioned, due to this, required during scheduling, ignored during execution, this pod is not able to schedule because this one is not met. The first one we discussed is required during scheduling, ignored during execution. Okay, the second one which we have discussed is preferred during scheduling. Okay, so let's do a quick demo to understand. So I'm going to create a file name called as preferred node affinity.yaml. If you see here, we are trying to create a pod. The name of my pod is preferred node affinity, and the name of my container is ABC, and the image is nginx. If you see here from line number 9 to 20, what we have mentioned preferred. In the last example, we mentioned about the required. Here we have mentioned about the preferred. So whenever we are using a preferred during scheduling method, then we need to mention wait. What exactly is wait? The wait in preferred during scheduling, ignored during execution determines how strongly the scheduler favors a matching node, with higher values indicating a stronger preference. It means, as I have mentioned, we have 3 node pools: large, medium, small. In the case of required, whatever the key I have mentioned and the value should be present. If it is not present, my pod will be in pending stage. Okay, this is same one which we have discussed in our last example. My pod is in a pending stage. Why? Because it is not able to match the agent pool which can satisfy this condition. While in the case of preferred during scheduling, it will try its best to match the pod to a specific node pool which you have mentioned, or else if the preferred node is not available, the pod will be created in different node pool. Okay, but in this case, the chances are there, 100% chances are there, your pod will not be pending. So let's do a quick demo to understand it. What I'm going to do here, I'm going to again update some random values here. Large 1 to 3, medium 1 to 3 1. Let me run a command called kubectl create -f preferred node affinity.yaml. See here, we are getting an error. So what is the error? It is regarding in the line number 4, we have to mention one space, and let me run it again. And our pod has been created. Let me run a command called kubectl get pods. And if you see here, our pod is in a running stage. If I'm going to describe this pod, kubectl describe pod, and my pod name is this one. Again, there's one typo. Let me sort it out. If you see here, it has successfully assigned my pod to a medium pool. If you see, and here in this case, my key is size, and again here the key is size. But do we have any labels on this name? The answer is no. Still, it has created the pod in a medium pool because we have mentioned preferred during scheduling. Okay, while still we have The last part is in a pending stage because we have mentioned it as required during scheduling. Okay, so with this we have completed our discussion for scheduler.